I'm here with Dr. David Clark from the Massachusetts Institute of Technology, who is one of the great pioneers and fathers of the Internet. And we are going to talk a bit about his contributions and his life. David, when you go back to your college and then later graduate degree years, you were planning to be a computer scientist or a network engineer. What was your vision of your future then?
Actually, I hadn't thought about networking at all until after I got my PhD. As an undergraduate, I was training to be an electrical engineer, but that's because my college had no computer science classes. But they bought a computer, and I fell prey to programming. And then when I was in graduate school, I didn't know what I was going to do. I was just interested in operating systems. And I was hacking code at that point. It was great stuff, you know. I really just liked writing code. I found the hardest machine I could to write code for, which was the machine that controlled the input-output, which was much harder to program than assembly language. So I was off having a hack attack. And it sort of got me interested in I/O. And I realized that networking was different because you couldn't handle it the same way for a very technical reason having to do with the fact that when the packets arrive in the operating system, you still don't know what process is supposed to get them, so you have to look at the header. And I said, oh, that's technically hard. And then I got gradually sucked into managing the group at MIT that was doing the implementation of the ARPANET protocols for the operating system we'd built, which was Multics. And then this thing came along called TCP/IP, and it looked sort of interesting, and I started going to the meetings. And it was entirely an accident. There was nothing planned about any of this. It was just, you know, maybe fortune favors the prepared, but I just fell into it. Happy accident.
And when you fell into it, was that sort of very gradual, or was it really a moment of revelation, and then you were hooked for the rest of your career?
Oh, it probably took me 2 meetings to get hooked. It was interesting because the advice I got from the senior faculty at the time is that networking was boring. It's just protocols. And I think it may be more to it than that. But there was tremendous camaraderie. That was really what was going on in the beginning. There was this spec for this weird protocol called TCP. And what we were trying to do was to make it work. And that meant both making sure the spec was correct and making sure the spec was comprehensible. And it was, for each operating system, I was writing the code for Multics, and somebody was doing it for 10X, and somebody was doing it for IBM operating system, which was a terrible problem, and a couple of real-time operating systems on digital equipment and so forth. And every once in a while, we'd get together, and we'd have what we called a bake-off, which is when we tried to see whether our code would actually interoperate. And it was just tremendously exhilarating. And there were only about 12 of us, so we could do anything we wanted. So I got hooked pretty quickly, but I didn't know where it was going to go. We had no idea where it was going to go.
So it seems that, did you have an opinion of TCP at that time? Were you thinking it was high quality, or that it needed a lot of improvement, or weren't you thinking at all?
Well, as it was originally specified by Bob Kahn and Vint Cerf, it was very different from the way it came out. TCP, we're having a very technical discussion here, but TCP and IP were rolled together into one blob. And there were actually several very smart people, and I wasn't one of the ones who was pushing for this, who broke it into 2 parts. And that was really the insight that the ends need to do one thing and the center of the network needs to do another thing, which was never completely clear in the beginning. I mean, if you go back to the early stages of the ARPANET, when I wasn't involved in this at all, I was still trying to get my master's thesis done. They thought all of the packet processing was going to be done on the hosts until the people who had bought the host machine said, you're not using my resources to do that, give me another computer. And so they gave them an imp. But it was really around 1978, 79 that the structure of TCP froze. And we knew at the time that it only did one thing, which was deliver bytes reliably in order. If you wanted unreliable delivery, you were on your own. But I think TCP did a pretty good job. I know that the things we did wrong, we did some small things wrong, but you know, we thought reliable delivery was the foundation for a whole bunch of stuff we needed to do. And it's just get this done and get some applications built.
Mm-hmm. When people talk about you today, they often talk about the Endtoend Principle and your paper as sort of defining and enunciating the Endtoend Principle. In a way, that is a nice segue to what you just talked about, because it deals with the issues of who does what, of what the center does and what the edge does. Mm-hmm. Could you sort of retell or how you got into this, how you moved towards thinking about the end-to-end principle?
Well, first of all, the end-to-end principle is not something that the three of us created in 1982. It was our attempt to articulate and give a name to something that was perhaps implicitly but nonetheless well understood. And so we don't want to take credit for inventing something. We want to take credit for naming something. But sometimes putting a name on something is really important, because then you can talk about it. Even if you disagree with it, you can say, you know, well, he has his principle and here's what's wrong about it. But everybody knows what you're talking about when you name it. And we struggled a little bit to try to understand, and this is before we wrote the paper, we struggled a little bit to try to understand what the network should do. And very early on, we had a kind of a computer science minimality principle, which said, you know, the less the network does, the more likely it is we'll get it right. And the more guns you put in there, the more likely it's going to have bugs and screw up. So what does a network do? Well, the network in the internet architecture involves forwarding packets. So we said, that's all we should do. We should be completely indifferent to the meaning of the packets. We should be completely uncaring about anything, except the packet comes in, the packet goes out. And so we took a sort of a rigorous point of view there. Now, the end-to-end principle actually says something that's a little stronger than that. What it says is, if you took an opposing point of view and started to put additional functionality into the net, for example, to ensure the correctness of the delivery, you can't be completely successful, because correctness has to be checked end to end. So anything you put in the net is just a performance optimization, and think twice, because you probably don't need it. Mm-hmm. Okay, so it was a correctness principle. So there's a minimality principle that says throw it out of the network, and there's a correctness principle that says you have to check it at the ends. Those turn out to give you the same answer, two separate principles.
Mm-hmm. Once you named it, was the name sticking relatively quickly?
I think so, but I don't really remember. I think it stuck pretty quickly. Mm-hmm. Yeah, that's sort of lost in the mists of time.
Mm-hmm. In the early 1980s, you became the chief protocol architect. Now, that's a wonderful title, but it's also a tremendously, I would imagine, in hindsight, tremendously powerful position of governance of the process. How did you get that position?
So you want the true truth?
We can do two takes.
No. During the 1970s, the man who oversaw this whole process was Vint Cerf. And he chaired the working committee, but because he was a program officer at ARPA, he also controlled the purse. And so he had two ways of coercing people. He could persuade them by force of intellectual vigor, or he could defund them. Okay, so it's the carrot and the stick. And sometime in the early 80s, I don't remember exactly when, he decided that he wanted to go off, and in fact he went to MCI and he did MCI mail. And so he needed to appoint a successor. And he took me aside and he said, you know, I was very pleased, of course, because he praised me for my intellectual leadership. He said, I want you to take over running this committee, which met periodically. And I said, well, I'm pleased, but how do I make it work? And he said, well, you can't control the purse, so you're going to have to coordinate with the guy at ARPA that controls the money. All I can give you is a title. And in fact, the title had no power whatsoever. So it was the absence of power that made it very effective. And I think people misunderstand this sometimes. People want to accrete power, and then nobody trusts them, and it becomes a very adversarial relationship. and I had no power, and I very clearly reminded people I had no power. So the only power I had was persuasion, but they didn't have to distrust me. So he really sent me forth into the world with, you know, a title and his blessing, and that's, you know, and that's what that's the fuel we flew on. That, and every once in a while I'd talk to the relevant program officer at DARPA and say, the carrot's not working, find the stick. But that was a quiet conversation off to the side. And so, you know, he invented a title for me, he invented a title for John Postel, and then he went off to MCI and did MCI Mail. And the committee was very informal. I mean, we changed its name a couple times so that people wouldn't be able to find us. You know.
Looking back at these 8 years or so in the 1980s, do you have what kind of memories come back? Good memories? How would you characterize that?
You know, the 70s were the period when we just tried to get it to work. I remember going to a bake-off, and we couldn't get anything to work. So we finally realized the problem was none of us had implemented the checksum algorithm right. So we all turned off the checksum algorithm in our code. We took one day and got that to work, and then day two we turned the checksum algorithms on and we got that to work again. Gosh, that was difficult. The 1980s was a period when we realized it was going to get big. And if you look at what happened in the 1980s, we dealt with bigness really the only default way that a computer scientist knows how, which we make it into a hierarchy. We used to have a flat routing architecture. We made it a hierarchy with an external routing protocol and an internal routing protocol. We used to have a flat namespace, things that we now are called domain names. They were just names, and John Postel maintained that list, and he'd print it out and send it to you. We realized that wouldn't work, so we invented a hierarchy. And there was a day when we had a network meeting and 100 people came, and we said that won't work, so we made it into a hierarchy, and we created working groups, and then eventually we formalized that into the Internet Engineering Task Force, and then we created the whole thing. But that was the formalization of something. That all happened during the 1980s. And of course, the other thing that happened in the 1980s, two pieces of technology happened in the 1980s, which is personal computers were invented and local area networks invented. And people said to me, did you ever imagine you were going to hook all the computers in the world together? And I said, oh yeah, we thought there'd be 100,000 of them. So it wasn't quite the same challenge as when we thought there might be 1 million. So once the PC happened, we realized that the game was different. So one of the minor little things I did, which I'm actually amused in a sort of in passing, was I wrote the first implementation of the Internet protocols for the IBM PC. Because when IBM started thinking about networking the PC, they wanted to hook it onto SNA. And so we said, well, we can probably hook this on, and we actually had a network that the PCs were on. It was a token ring at the time. And so I did TCP for the IBM PC. It was really interesting. There was enough memory, I could have enough buffering for one packet. And that made it slightly interesting to get it to work. But the 1980s were really the time when it was just getting big, but it was still exhilarating, and it was still, we didn't, you know, you really couldn't, it hadn't gelled or frozen yet. It was still very plastic.
When you forward to the 1990s, I went back to a stack of presentation you gave in 1992, if I recall correctly. And in it you said, interesting new things on the horizon, Gopher and World Wide Web. In that
Waze and a couple of others, yeah, right.
And I still remember Gopher, but I'm a very small part of a very small community. When you came across the World Wide Web for the first time, or was that an aha moment, or?
Well, yes and no, in the sense that the World Wide Web was not the first hypertext system. There had been previous ones. There was Xanadu. The idea of hypertext wasn't new, so it wasn't quite clear in 1992 whether this was the version that was going to make it. I'd always believed in hypertext, and I think that talk is a nice time capsule. I think it's good to go back and see what you actually said as opposed to what you think now you said back then. And it was clear back then that we knew the World Wide Web was a very important candidate, but it wasn't clear it was going to win yet. Because I listed them all as equals, you know, Wace and Gopher and Archie and whatever else was in that list, and the World Wide Web, which I didn't know how to spell, if I remember correctly in the slides. I didn't say www, I think I said W3 or something like that. That's right. So it was right at that point where we knew that an information architecture was really important, and we didn't quite have the confidence to predict which one was going to win.
As the path of innovation progressed all through the 90s, and then the internet bubble into the 21st century and so forth, have you ever been taken aback and said, "Oh my God, this is moving so fast, and at such a complexity now that I have difficulties keeping up"?
Oh, absolutely. Oh, absolutely. I resigned as chief protocol architect. I remember the day Marshall Rose said to me, "I can no longer read every RFC that comes out." He said, I give up. But it was clear to me nobody was in charge, nobody should claim to be in charge. I thought it was presumptuous to have that title, and I wished not only to resign, but to retire the title, which I think I effectively did. There's never been one. And I realized that, yes, it had gone chaotic, it had gone out of control, and I think it took us a while to figure out how to play a role. But, you know, I really turned back to research in the early 1990s. I really backed away from this stuff, and the particular topic I wanted to work on was quality of service, because I saw internet audio and eventually video and coming, and I figured we needed quality of service. I was the ritual victim told to stand up in front of the IETF and argue in favor of quality service to a community that passionately believed in single best effort service. But I absolutely backed away from the idea that anybody or anything could be in charge of this. It was just out of control, in a good way, but it was out of control.
In a way.
And this is before the real influx of commercial innovation.
This is still when the rhetoric was the information superhighway, the early 1990s, I imagine.
This is the Al Gore period, the information superhighway, and you know, again, I have a couple of benchmarks in this space, which, you know, we're not talking about here today, but we did a couple of studies with the national academies. We did one called Realizing the Information Future in 1994, and then we did a follow-on one called The Unpredictable Certainty, which Lou Branscombe chaired, I think. Yeah, I think Lou chaired that. And those are also interesting time capsules to go back and see what we understood back then. But this is just at the beginning of the commercialization of everything.
I went back to Realizing the Information Future, which I have in my library, of course. And what seemed striking to me was the interest then, in general, in the people who were involved, but also with yourself, in governance, or in the structures of how decisions are being made. And it's not obvious, it's not explicit, but it's implicit in a lot of what is in there, I felt.
I should go back and read that again. I really should. The committee that wrote Realizing was very interesting, because we had representatives of the telephone companies who were by and large conservative. One of the things you'll notice in there that we defined something called the Open Data Network, the ODN bearer service. And people who go back and look at that today and said, that's the internet, right? But the committee wouldn't let us call it the internet, because they were convinced that the internet was the prototype of something that would eventually be designed properly by people who really knew how to build a net that was manageable and so forth. I wanted to make up a bumper sticker that says, "This is not a test," you know. But the internet is mentioned in there, but in the formal diagrams and so forth, we could never call it the internet, because they were convinced that this was just a somewhat flawed proof of concept. So part of the question that they were worried about was the question of how to manage that transition. And of course, the internet's had a succession of competing ideas, from the commercial vendor-specific protocols, DECnet and the Xerox Data Network and SNA, and then the ISO's OSI, eventually, then you begin to see the telephone company trying to say, what are we going to do? And they come in with ATM. And so I think we were less concerned with how to govern the internet, which we really thought we could do pretty well out of our back pocket. If you look at what John Postel did, giving out IP addresses and so forth, it worked pretty well. What we were really concerned with was this terrible contention between competing ideas. And, you know, the federal government was very bifurcated here because because NIST, as the official representative of the formal standards-making machinery, really felt that we had to go with OSI. And NSF, thinking that the market was going to pushed the Internet Protocol suite. So you had dueling parts of the government here. And I really think that in the 1990s, it was really this process that we were paying the most attention to. And in a very blunt sense, how do you win in this competitive space? You know, what do you do? And having a product is not enough.
What, if we fast forward to today, what sort of keeps you awake today? What interests you most today, if you think about the internet?
Well, what interests me most? I mean,
I know you work with political scientists.
Yeah, I work with
I say.
I work with political scientists, yes. It was in the 1990s I realized I had to hire an economist. It was in the 2000s I realized I needed to hire a political scientist. I think that I'm less interested in polishing the data plane. If you go to our traditional networking conferences, there are people still optimizing the data plane, and we've been doing that for a long time, and sort of polishing the round ball. Clearly, left over from the 1990s is a tremendous recognition that if we don't get the industry incentives and the economics right, the best idea won't take. So the fact that we don't have quality of service in the internet today is not because the technology is flawed. In a lot of corporate networks, it's turned on and it works just fine. It's because there isn't an economic framework that motivates everybody to do it. The wake-up quote for me, and it was in the mid-90s, I tried to persuade the CTO of a major ISP to turn on quality of service, and after he said no, and a few rude things, he said, why should I spend a lot of money to install quality of service so that Bill Gates can make a lot of money selling internet telephony for Windows? That was a pivotal moment for me. I said, ah. So I really got interested in trying to persuade the community to think about the industry structure that protocols induce, which is a sentence that makes a great deal of sense to an economist but doesn't make any sense to a computer scientist. I've had to push people in this. So
I would imagine it also makes a great deal of sense to political scientists who study the structure of governance mechanisms all the time.
And you know, economists use this word of incentive and motivation, and political scientists talk about power and control. And so part of what I've been doing with my political science collaboration is to find an alternative way of analyzing the internet from the point of view of what control points the protocols induce, because sometimes you can eliminate a problem by simply removing the control point from the technical architecture. The domain name system has a root, and computer scientists solve problems by creating hierarchies. The problem with hierarchies is they have a root, or a top, depending on which way you point the tree. The DNS didn't have to have a root, it turns out. It's much harder to build a name system if it doesn't have a root, but you can do it. If you look at the way we do routing in the internet, it's a hierarchy, but there is no network in the center. We didn't allow one network to be the network in the center that becomes then the monopoly that hooks everything together. We deliberately engineered it so there's not a single guy in the middle. We could have done that with the DNS. If we'd understood enough to do that, we might not be having any of the arguments about the DNS that we're having today, because you can't fight over the root if it doesn't exist. You know, so we didn't think about the social construction of, or the governance construction of the DNS. By the time we got to Border Gateway Protocol, BGP, we absolutely understood about building a protocol that induced the right industry structure. In particular, do not create a monopolist in the center.
We need to slowly wrap this up, although I could go on for the entire evening. And I would get a great deal of new insights out of this. But I wanted to ask you as we part, if you look back at your career, would you do it again as you did? What would you do differently, if any?
My initial reaction is not a thing. My initial reaction is almost everything I did was accidental. But, and I have to say, I have students come to me now who say, well, you've had a very interesting career. How did you plan all that out? And they're tremendously upset and disheartened when I say, I didn't plan anything, you know. And I really do give people advice to say, do something you really like, because then you'll be happy doing it and you'll enjoy it. But fortune favors the prepared, you know. Study lots of things, read lots of things, and see what opportunity comes along. I mean, if I were doing it today, you know, if I were getting my PhD today, I don't think I'd work on the internet because it's mature now. I want to do something else, like, you know, oh, I don't know, biology or how the brain works or something like that. But no, I mean, if I could go back and replay the story, I'd go back and replay the story. I had a great time. It was a lot. I'm sorry, this is not a lifetime essay. I don't have to quit now, right? I mean, no. You know, this is in the past tense. I'm having too much fun to quit. I always had too much fun.
Thank you very much.
You're very welcome.